Hi, and welcome to Infovis and VTK webinar. I'm Jeff Thomas from Kitware, and we'll be walking through some of the capabilities VTK has in terms of information visualization and data visualization. A few administrative items here to begin. We have very helpful Dave here to answer questions if you want to use the chat interface. And also want to let you know that this recording will be made available on the Kitware and VTK websites. So what we'll do today, we'll start with a quick VTK introduction, then move to a few different use cases. One is going to involve using tree views, and the other using graph views, or I'll call them node link diagrams, so that they're not confused with regular graphs that you might be used to. And then some introductory discussion of OpenView, which is a new application for exploring data with VTK Infovis views. So VTK is a visualization toolkit. I assume you may have heard of this already if you're here. But what it is a open source toolkit that's been around for decades, really, and it's written in C++, and it's been used to do all sorts of things around the world. Researchers have used it for simulations, medical imaging, data processing, all sorts of things. And these are the kinds of pictures you are probably used to looking at in relation to VTK. Today, though, I want to also show you this side of VTK. So VTK also does all sorts of new stuff, new as in maybe 5 years or so. Things have been starting to come in regards to information and data visualization. Things like tree maps and node link diagrams and various ways to show more abstract data. Lots of charts and those types of things. There will be a separate charting webinar coming up this year, so I'm not going to focus on the charts. But that's another capability we have. Now here's the one slide introduction to what VTK app is. So what VTK has up near the top of the slide is sorry about that. Is a set of a few types of classes. So you have readers, which will import data, filters, which do any number of transformations on the data, and this is where there's a huge number, hundreds of these in VTK. And then there are also mappers and actors which work together to transform data into graphical language. It mostly all goes to OpenGL. And then you have a renderer and render window. The render window, in the most basic sense, is kind of that is your window, that is your app. So what you do is you start with readers, you go through filters to mappers, actors, render window. And so an application in VTK generally consists of chaining those together. You hook them together by hooking their ports together, and then you tell the render window to start interacting, and everything just works if you've set everything up right. And with information visualization, this is no different. It's set up, it's split up into readers and a set of filters, and then some mappers and actors, which are packaged a little differently. We'll see that than you may be used to, but in general, it's the same flow. So we're going to start by looking at tree views and the tree data structure. So a tree you'd use for storing any type of hierarchical information of an organization or of really any type of groupings that you want to put on data, grouping financial data by by product or by region, really any number of different things you might want to do to group your data and see how it's arranged in a tree. For this in the next example, we're going to look at trees and graphs from the point of view of tables, because really most of the world's data is in tabular form. People have data in Excel or comma-separated files, and even databases are most often in this tabular form. So that's where we're going to start. And so this first part is how do you take a table and turn it into a tree? So we have some filters to do that. The first one is called vtkTable to tree. That one does the most basic transformation. It doesn't give any structure to the tree, but it just takes the tree, or takes the table and turns every row in that table into a child of a single root element. So we'll see that in a minute in our example. And then things get more interesting when you start pairing that, chaining that with these group leaf nodes filters. Each one of those will take one of the attributes of your data and group by it, so that it'll start grouping the rows in your table by values that match in a certain field. So, for example, if you had a table of articles and they had topics associated with them, either math or physics here, and you grouped on that topic column of your data, then you'd end up with something like this in the diagram, where maybe half of your data shows up underneath the math node and half under the physics node. But you see we're adding basically a level to the tree to represent that separation on that field. The second one, we just chained it with an author field, and then it'll also inside that, inside each topic node, it'll make subnodes for every type of author that appears in that topic. And then you can do so on and so on to make as complicated a tree as you want. So just to demonstrate how this works, so you actually use the order of your VTK filters to specify the order of the levels of your tree. So if you change the order of your group leaf nodes filters to first group by author, then by topic, then you'd have your authors A, B, C, D, E, and then these math physics nodes appearing underneath your authors, where if an author authored articles in more than one topic, they'd have multiple children like node B. So it's a fairly flexible way to create a hierarchy out of your data. Okay, so I'm going to move over to code now to show you how this works. Okay, to show how this works, I'm going to use data from the 2012 Olympics. So what we have here is a comma-separated file. The first line is telling you what the different things are, the different columns of your data. And you see we have country, the country code, the event, and the number of gold, silver, and bronze medals. It's a little out of order, but the number of gold, silver, and bronze that country had in that event. So this is saying that in soccer, USA got one gold medal. I think it was the women's team. So we're going to take this data and try to get a little better idea of what this data really says about what countries do good at what, and how they've in general, how the Olympics are organized by sport and which ones have more medals than others. So let's take a look at the code. So here, just a couple of things here. I'm using VTK new, which is a nice way to create VTK objects where you don't have to worry about deleting them afterward. It'll delete it when it goes out of scope. Yeah, let me just start going into this right away. So we have our delimited text reader, which will take our file, and load it into a vtkTable. So a vtkTable is just a set of columns, and each column has a certain type to it. So I'm going to specify a couple things in this reader that from the default. One is that we do have headers. We have a header column in our data. So we want to interpret this first row as the names of our columns. We want to detect numeric columns, which means it'll convert automatically. If it sees only numbers in a column, it'll convert that column to actual, fundamental type, underlying type. So it'll turn, for example, this gold column, because it only has numbers in here, it'll turn it into a VTK int array instead of just reading them as strings and keeping it as a string array, which is what it would normally do by default. And then this last one, output pedigree IDs, this is something that will literally just add a column that contains the row number, and that helps downstream algorithms to know what's what, and it keeps keeping track of columns as they're kind of shifted around through the data transformations. I'm not going to say more than that about that now, other than to just say we need it for this pipeline. So now we're going to use the filters we were talking about. vtkTable to tree is going to take your tabular data and convert it just into a basic tree. And I'm going to skip over this stuff for the moment. And we're just going to load that tree right into a tree map view, as well as a graph layout view. And we're going to use a basic layout strategy on the tree map. So let's just run this and see what happens. Okay, so this is not too interesting, right? So what do we have? We converted it into a tree, but like I was saying, it's just making all the rows. Here, if I zoom in, you can see it's just literally taking all the rows and making them into children of a single parent node. And you can see that in this form in the graph view that's using a tree layout strategy here, and also in the tree map view, which our tree map view is this idea of having boxes nested inside of boxes for visualizing a tree, which again is not interesting. Everything's in the same box. Even worse, we don't even know what box is what. So that's what I'll take care of first. So we're going to start setting properties on things and making our visualization better. So let's turn on labels for the different squares in our view, in our tree map view, and also turn on labels for the tree view. And I'm going to take this country event field, which contains both the country name and the event name, that pair, that's unique to each row. So I'm going to run that. You should see something a little bit better. So now we at least see that we have, France rowing here. So we know what that box means. And again here, you notice that VTK tries to do a good job at not making the labels overlap with each other. So that's a little better. But let's add a level to our tree. So right now, even though I had this group leaves filter in my code, I was wiring my view up directly to the table to tree, so it was just bypassing that entirely. So what I'm doing in the group leaf vertices filter is taking the country and grouping by that. And that I'm doing that with the set input array to process. That's gonna it's kind of the generic way of specifying what arrays to use inside VTK algorithms. And it has this kind of complicated API where the most important thing is the first argument tells you which one you're setting. So here you're setting the first one, or the 0th one, and here the second one. So the first one is going to be what you group by, and the second one is just saying when you create new nodes, those new nodes have a name, and what array do you want those new names to go into? So it's kind of it's a more nuanced thing, but it is important. You'll see in a second why it's important that we need to know where to put the labels for new nodes that we create. So let's go ahead and hook this up to group leaves instead of just table to tree. And if I did that right, okay. So now this is a little better. Now our tree map and our other tree view is grouping all the data by country. So for now, for example, you can see for different countries, China, Japan, Russia, that they kind of have more events that they've been involved in with metals, and countries that maybe have only gotten a metal in one area or a couple areas. So that's kind of interesting. But the the boxes are still very boring looking. They're kind of rigid. They're all the same size. So we can change that with the tree map view with our layout strategy. And for tree maps, we had set it to box. But I'm going to change it to squarify. So squarify makes things a little better. So all the red boxes, the lowest level boxes, are now the same size, and the green ones are getting bigger. That level 1, this level that represents the country, are getting bigger depending on how many events that country got metals in. So now we can see that China actually has a larger box, and Russia has a larger box here. Okay, let's go even further. We want to not just say that a country got a medal in an event, but let's change the size based on how well they did, how many gold medals they got, for example. So for that, we're going to use a new filter called vtkTree field aggregator, which is going to take a field here, the gold field, and build up valid values on all parts of the tree, not just the leaves of the tree. So again, that's kind of nuanced, but the idea is we don't know what the value of gold is for example, an entire country based on the original data. We have to do a little bit of aggregation to fill those values back up the tree. So that's what this aggregation filter is doing. So now if we use this one instead, and make it so that we use this gold column as our area size, instead of using a constant size for all the leaves, should get something a little different. Yeah. So now, for example, you start to see even more detailed things like here, the biggest box is USA Swimming due to Michael Phelps, the kind of large number of gold medals. And you can see some of the more disproportionate things going on. Here, Russia track and field also got quite a large amount of gold medals. You can kind of now start to see, okay, this is where they excel. China, gymnastics and weightlifting. So this is getting more to where you really can start seeing some of the detail in the data. Okay, so now just for fun, we're going to switch the order, or switch actually the grouping array. So now instead of country, we're going to look at the event. So let's see what happens. So now we're just constructing this tree differently. It might be easier to see here in our other view how this worked. So now instead of countries here at level 1, our group tree filter created events here. So now the size of the box, the size of the box here is going to represent the total number of gold medals that were awarded in each of these events. So there are obviously events that have much more numbers of gold medals than others, and you can also pick up on things like the fact that there are some, and the labels aren't showing up in some of these, but for example here, the table tennis all went to a single country. It's actually hiding underneath that table tennis label, so I can't see what it is directly with this view, but it's just another way that you could organize your data, and just looking at it from different data dimension. And you can again kind of stack these things together and make this tree as complicated as you want. Okay, I think that's all that I'm going to do for this one here. I want to get back to our second example. Let's see. All right. So now I want to talk about node link diagrams, which in a way is just a more general version than the tree diagram. So node link diagrams aren't necessarily a hierarchy, but you have these arbitrary relationships where as anything goes, anything can link to anything else. There's no really top or bottom to these diagrams. It's just a mashup of all your data together. So just like trees, I'm going to talk about creating graphs, again, from tables, because that's where the data usually comes from. And appropriately named, we have a filter called table-to-graph, just like table-to-tree, except this one does the whole thing. You specify everything that you want to do, and it's generally all you need to do is embedded in the single filter. So table-to-graph takes in one table or two tables and swizzles them together to create your graph. A graph is made up of the nodes of the graph along with the links. So the tables that come in are the properties of each of those. So the table that's normally the most important is defining the connectivity of the graph, and we call that the edge table. And the one that defines additional properties on the nodes or vertices of the table we call a vertex table. So since to define the graph, you really need the topology and link structure, the edge table is required. Vertex table, you don't have to add additional data to each vertex if you don't want to. And it takes this idea of a link graph to tell it how to transition the edge table into an output graph. So next few slides will explain that a little better. The most basic case is you have two columns in your table and you want to associate them with each other. So one example would be if you had communications data and you had a from and a to, then those would be the fields that, or the columns that define the linkages in your data. Here we have a document, and it might have been associated through maybe some algorithm, or somebody tagged them with these certain concept numbers in order to add some structure to these documents. So if we wanted to see what documents were linked to what concepts, we could create a link graph that will just link here in the middle the document field to the concept field. For every row in the table, it'll create one link, and then you end up with this output graph. So this is the most often the use case that you'd be looking for, where you're just linking two columns together. It does allow more arbitrary things. So for example, if we're looking at our article data again, where we have the article, maybe the article name, author name, and a tag associated with it, then you could make your link graph contain more than 2 columns. And now for every row in your table, you're going to make 2 links. You're going to make a link between that author and article that article and tag. So now your output graph really has 3 types of things in it, articles, authors, and tags, and they're just all kind of linked together if there's any row that contains both of them together. So for example, the first row would turn into a link between A and A1 and A1 and math. Okay, let's go back to the examples and see this one working. So for this example, I'm going to use domain registration table, which is not application for a regular domain name, but actual applications for top-level domains. So this was opened up by whatever organization governs the internet as an idea to let companies basically be able to manage different top-level domains. So instead of just .com and .org, you can have .baby or .person or whatever you want. So this table shows all the applications that were made for a company to be in charge of a certain new top-level domain. And then some interesting things happen because you can see things that there are differences maybe in different parts of the world. There are differences between different companies that are maybe competing with each other in certain areas. So this is a kind of interesting data set to look at. Okay. Now you saw the vtkGraph layout view in the previous example, which I was using to build the tree. Here I'm going to use something a little newer that we've been rolling into VTK that has a little bit different strategy of how you specify things, and it's another way of doing it. You can it involves more programming, but it's more flexible. You'll see what I mean there. But again, we're going to start reading in the table. Nothing different here. Now we're going to use, instead of table to tree, table to graph, and the idea is we have to build that link graph, that template graph, in order to tell the filter what to do for every row in the table. So you do that by adding link vertices and link edges, just as if you were constructing just a little graph. So in this case, we're adding vertex for applicant and string, and so that's telling you what columns these vertices are referring to. So again, this link graph has its vertex space is the columns of your data, and then you link them together with edges. So so applicant and string are two of the columns that we have in our data, and then we want to link them together. So it's that simple use case of linking 2 columns together, kind of the most common use case. And here you can set whether you want your graph to end up as a directed or undirected graph. Here we're setting it as a directed graph. So the only thing I didn't explain here is this domain 1, domain 2. So this is another one of those nuanced things, but it can be important. So what if you had so from and to maybe addresses or Facebook names or something, and you wanted, no matter which column it was in, you wanted the same person, like Tom Hanks, to be this, to resolve to the same node in your graph, no matter if he was in the from or the to. That means that really those 2 columns are in the same domain. And there are other cases, like here, a string and applicant. If there is an applicant name that happened to match one of the top-level domain names, the strings just happen to match for some reason, you wouldn't want those two to be resolved because they're two different things. So really the only thing that we're specifying here, the string really isn't important. What's important is that they're different. So here we're saying these go into two different domains. And if you knew from your understanding of the data that two columns were really in the same domain, you'd make them match. So that's the explanation of that. Now going to the view, you can do various types of layout strategies on your graph that will pre-compute the locations, kind of an XY space of where those nodes are based on what it's connected to try to make a nice graph where it'll let you see things that are connected a lot with each other will appear closer together. And then we're going to use, so graph layout basically is the algorithm that takes those strategies and runs them on a graph. So these strategies are not themselves filters, but you plug one of the strategies into this generic graph layout filter, and then that's how you can plug it into the pipeline. And at this point, things change a little bit. So we're talking about the some newer stuff that's been incorporated into VTK in the last couple of years, having to do mostly with the charts, but there is a graph item in this as well. It's more of a scene graph-based approach where you can make a hierarchy of items, and it'll render those by calling paint functions. And so it's a bit different of a model. So I'm not going to get into all of how that works, but I'll explain how we build this scene for a graph. So really at the top level is going to be a transform, and that is going to be an interactive transform, and that's going to let us pan and zoom our scene. And then attached to that transform is just a single item underneath it, which is the graph item. And so this is our slightly customized item we'll see in a few minutes that renders a graph. And we put that inside an actor renderer render window. So that part is the same as you might be used to. And we have our interactor style. We have a special one for this 2D scene, and render window interactor that we start up and do our visualization interactively. I'm going to turn that off for just a second, just to show you. So going back here to how we set this up, we're using random strategy right now. So let me switch over to the right project. Okay, so this is the random layout strategy. It'll literally just put nodes anywhere. As you can see, it's not a great way to do it. That's why I'm starting out with it. But you can see a lot of stuff coming out of this one node here, and that is Google. You can see over here there's another high degree node here, top level domain holdings limited. So you can see a few things here, but obviously this is not the way you'd want to lay out a graph, and this is the it could be a starting point, kind of an initialization of at least getting things spread out in space and then starting a layout algorithm on it. So I'm going to switch over to one of these other ones to show you what a different layout strategy does, the simple 2D layout strategy. They all have the same basic concept as that they will try to minimize edge lengths and make it so edges aren't crossing each other. So this one, it was pre-computing for a few seconds there, and then it actually ended up over here. This one kind of ends up in this interesting diamond shape, but you can see this is much better. Now we can see some of the high level, and my node flipped out on me. going to show you in a second the way that you generally use this new item that lets things happen in a much more fluid way. But I just wanted to show quickly how these layout algorithms worked. Actually, I'll switch over to that now. So what I'm going to do, I'm going to go right to starting with a random strategy, but then turning on the layout animation. So here now we're starting to you can see right away it comes up much more quickly, and we have this nice interactive view where you can click on things and also even get a hold of it, drag things around and do fun stuff. So you can see how it's doing this optimization problem where things are trying to get close to each other, and you've probably seen something like this before. And here, so now we can explore a little bit more. There's Google and Amazon. You can start to see some of the red ones, which are the domain names, the top level domains. The ones that are most common are going to be ending up toward the middle of the graph. And you can see, book, tech, CPA, love. So, and there's actually a lot of kind of weird and interesting things going on here. But really, this is where the kind of action is of companies that are competing over these top-level domains, and you can see that because of kind of how many linkages there are. Even if you can't always follow exactly where they all go immediately, you know that if they're in the middle here, there's some competition between various companies. Map, that's another one. All right. So let me show you a little bit about how I rendered this. So let me go up to here. So you had seen my graph item. So what is my graph item? Well, I took graph item and I customized it. If you don't customize it, it's a pretty basic view of a graph right now. It'll show dots and links, and that's pretty much it. Everything will be the same color, and it will be very interesting. So I added a few things to this. Some of the capabilities I'm talking about may go right into VTK. Some of them are already in OpenView that I'll show you in a few minutes. But just wanted to show in this webinar this newer way of doing things in case you need something more customized. This definitely lets you do more than just kind of set an array for color. It lets you, for example, have it based on a complicated conditions of what color you want it to be. So here I'm saying if it's the one you clicked on, I'm going to make you red. If it's one of the domains, I'm going to make it greenish, and if it's the other domain, I'm going to make it reddish. So here, for example, if I don't like green and I wanted to change it to blue, make the blue component higher. Let's say like we want them like partially transparent or something. And we run this guy. Now they're partially transparent, and then we have blue. So it's the kind of thing that's makes it a little more simple to get exactly the kind of view that you want by using this by overriding these virtual functions, which will be called once per item, either the vertex or the edge. I'm saying that the label that I want to appear when I do click on something is going to be from the label field, which vtkGraph automatically puts in there for me. If you remember, we weren't using a vertex table, but vtkGraph will create vertices and create this label field automatically based on what that vertex represents. And then we did the same thing for edge color and width, but nothing interesting there. We're just specifying constant values for the color and the width of the links. And then here, again, this is something that will probably make its way into VTK proper, but this is just showing you can do some customized things like when you click, I want to draw the string of that label, of that vertex for whatever one was focused on. And I changed the one that was focused on based on whatever one was clicked on. And so you could easily, for example, to make interaction with other parts of an application, when people click on different parts of the graph, you could just override this method, pull out the hit vertex, and then tie it into your application code to do whatever you want. So it's something that what used to be a little more involved or not very tractable with the graph layout view. But a lot of this also is possible to do with graph layout view if you're interested in setting those fixed kind of set of arrays for labeling, coloring, and things like that. So this is just another way of doing it. I wanted to do a couple more things with this. I wanted to change around our link graph to see if there's something else we can look at here. So instead of tying the applicant, or this is the company name, to the domain name, let's try tying. Start with region. So now we have red again as our domain names, but now we have very few blue ones because now everything's grouped into region, which is actually a very large geographic region. Like this is North America, and this is Europe. So you can see most applications work from North America and Europe, and they are conflicting most often with each other. And then there's less from, I think that would be Asia Pacific, and Latin America possibly, Rio. I guess that makes sense. Okay, so there's another geographic one that I'll switch to. I think it's called location. And this is a little more resolved. This is the country. So you probably guess what this thing in the middle is. I'm not good with country code, so but again, something that's kind of in between these blue nodes is going to be something that's more shared or more conflicted between these different countries. So a few countries applied for a coupon. So just to show what happens when you change your link graph and how it structures your data, all just coming from the same table. Okay, I'm going to go back to my slides now. Want to just give a little introduction to OpenView. So OpenView is our new kind of new effort at making a smallish but kind of somewhat powerful application for exploring using Infovis, and at least as a way of seeing what's possible to do with VTK and some of the different views that have been existent there for a while and ones that are going in more recently. And the general structure is you have a big view area. You can load data, which appears on the left, and then you choose your viz technique and can set a few parameters. So let me bring this up here. here I'm just browsing for file to load. And just, I'll load a different one. Those other data sets are available. The ones that we've been looking at are available in a zip file that you can get at from the OpenView website, which I'll show you in a second, as well as a few other ones like this one. So this is actually showing the VTK class hierarchy. It's showing it in a graph view, so it's not showing it from a top-down point of view. But you can see, for example, VTK object has a lot of direct subclasses, so that subclass relationship is what's being shown with the linkages here. And you can see I'm using that same graph item, but I made it just a little more advanced. I am highlighting not just the node that you click on. I'm actually highlighting what you hover over, as well as the things adjacent to that. So it's just another example of how you could customize the graph item. So here you can see, like I was showing you at the beginning of the slides, VTK algorithm. These filters really make up a lot of what VTK is. This encompasses kind of, I don't know, basically half, or at least half of the source code in VTK is all these different algorithms. You can see other interesting things, all the data arrays, interactors. So it's another fun data set, especially for VTK tutorial. So let me bring up the, let's say, well, let's try this. I'll bring up the Olympics now as a graph, just for fun. So now it's linking countries to the various events. So you can see here in the middle are events where lots of different countries win medals. And then things around the edge, there's less and less kind of either less participation or less more domination by certain countries. And here, if I well, here, yeah, I don't want to change that. It's probably the best way to look at that data. But I wanted to show one more thing. I was going to take our domain data, which again, this is that same data we were just looking at, but show that you can see it in a tree map. And this is kind of the 2.0 version of a tree map, which is not yet in VTK, but same idea. And if I take the, for example, like the location, then I'm seeing all the different applicants that are within the U.S. and all different countries, kind of sized by how many they they submitted to those to that. So there's a few different things. I'm not going to look at the plots really right now, but and this is still getting populated with what's possible. There's a tree ring view, which shows a tree, but just in a organized in a ring form instead of boxes inside of boxes. Now you have wedges underneath wedges, kind of thing. Yeah, I think that's pretty much it for what I wanted to get through today. So I can see we're nearing the end, and just to point out again that there are resources available at vtk.org, and that this webinar will be made available there and at kitware.com. And the OpenView application, if you're interested in learning more, and also I think I'm there for the contact on that. So if you're interested in learning more about that, you can contact me. And the site is openview.kitware.com. We have there's a Mac installer available, and we're working on other platforms, but they're not there yet. Hopefully within the next month or so, you start seeing some other stuff there, since this is kind of still alpha type of thing. So with that, I I think I'll close it up and see if there are any questions that I can answer. I'll take a look at the chat now. Let's see.
Ready to the slides.
Okay. Well, I'm not seeing anything here right now, so I think we'll call that a webinar. I appreciate everybody who was able to attend, and look forward to seeing what people can do with Infovis and VTK. Again, contact the VTK developers list or contact me, and be glad to help you out some more. Thanks.